Alright guys, what I do on the board, you're going to do on your paper. So every line that I draw, every mark that I do, every number that I put down needs to be on your paper. Alright, for the first problem, we are drawing one number line with two endpoints. On your left endpoint, I want you to put a whole number 0. And on the far right endpoint, a whole number 1. All right, now I want you to divide your number line into thirds. Now I'm going to do it on the board so that you can see in just a second, but I want you to try to do it on your own first. Divide it into thirds. Alright, so divided it into thirds, we need to make sure that we keep in mind that this 0 endpoint, do we count that line? No. No. So we're only going to count this line here, this last endpoint, and that's the last line of our thirds. So how many lines do we need to have in the middle of our number line? Cornelius. 2 lines. Okay, so we're going to divide it, and we're just going to eyeball 1, 2. Alright, so the first line, after our 0 endpoint, the first line is going to be what fraction? Go ahead and say it.
1/3.
1/3. Alright, the second line is going to be what?
2/3.
And the third line is going to be what?
3/3.
There you go. Now, pay attention to what I'm about to do. I want you to do it on your paper too. Who can tell me what addition equation I have just modeled on this number line? Talia. 1/3 plus 1/3. How did you know that I had just modeled 1/3 plus 1/3? All right, and each time I jumped was what? Was 1/3. So we have 1/3 plus 1/3 equals what?
2/3.
2/3. Okay, does anybody not understand what I just did? Okay. All right, let's look at another problem. All right, for this one, again, you're going to draw a number line. Label your 2 endpoints, 0 on the left end and 1 on the right. This time, I want you to divide your number line into fourths. Alright, so your number line should look something like this. So with fourths, we're going to take one line down the middle, and then half that half, and half that half. So you should end up with 4 lines total after the 0 endpoint. Does everybody have 4 lines?
Yes.
Okay. They need to be close to equal, but nobody's going to bust your chops over if it doesn't look perfect.
Yes, ma'am.
Alright, so the first line after the 0 endpoint needs to be what fraction?
1/4.
1/4. The second line is what?
2/4.
The third line is?
3/4.
And the fourth line?
4/4.
Alright. Watch carefully. All right, what addition equation, excuse me, can I show with what I just did here, what I am modeling? Here. All right, so we have 1/4 plus 1/4 plus 1/4 equals what?
3/4.
3/4. And so we are showing that with our jumps. We jumped 1/4 section, we jumped another fourth of a section, and then we jumped another fourth to end up with 3/4. Are y'all ready to increase in difficulty?
Yes, ma'am.
All right, we're going to draw another number line. Again, your endpoints, 0 and 1. And this time you're going to divide it into eighths. Jake. Eighths. Think of fourths, and then divide those fourths into half. And you should have a total of 8 lines after that 0 endpoint. Alright, so to do that, just like I said, we're going to divide it into fourths. So I divide mine into half, half, and half. And then half that fourth, half that fourth, half that fourth, half that fourth. So we end up with 1, 2, 3, 4, 5, 6, 7, 8. All right. Notice I'm not going to label it yet. Now, if you already did, that's okay. I'm going to do who can tell me what fractions lie at each of my landing points? We'll call them landing points. Which ones are there at my landing points? Maitland.
3/8 at the first two, and 1/8 at the last one.
So this is 3/8 and this one is also 3/8?
Yes.
If I'm doing a number line though, if this is 3/8, how did you know that this one was 3/8?
Because I skipped the first one and then I counted 3.
Okay, so 1, 2, 3/8. So then what would this one be? 4/8. And what would this one be?
5/8.
And then what would this one be?
6/8.
Okay, so it's not another, if you're doing a number line, you're not going to write 3/8 twice, even if you did jump 3/8 both times. You're labeling a number line, kind of like a ruler. Okay, so you're not going to have 3/8 on there every 3/8. You're going to go up and what it would actually be. All right, so what is this last ending point going to be then?
7/8.
All right, Jabir, what is it?
7/8.
7/8. All right, now 7/8 is our answer. I want 2 equations that show me how I could have gotten 7/8. One of the equations I want to be strictly addition, and the other one I want you to throw in some multiplication.
Yes.
How could I have gotten to 7/8 using this model only? Only this model. Carter.
We should do 3/8 plus 3/8 plus 1/8.
All right, so Carter nailed the addition one. 3/8 plus 3/8 plus 1/8.
I do much different.
You have to do it as the model shows, though. There are lots of ways we could get to 7/8, but based on this model is what I want the equations for. How could I use multiplication to show this model? And I'm emphasizing some things that might help you. Same.
1 times 3/8 plus 1/8.
1 times 3/8. Isn't 1 times anything? That thing?
So, no, 2 times 3/8 plus 1/8.
All right, why 2? Why'd you change it to 2?
Because you did 2 big jumps, and in each 2 big jumps there are 3 lines, 3 spaces.
All right, 3 sections, 3/8. All right, who can tell me the definition of multiplication?
Oh.
What is the definition, the mathematical definition of multiplication? Talia.
Repeated addition.
Repeated addition. What 2 fractions were repeated in this problem?
3/8.
3/8. How many times were they repeated?
2.
2. So we have 2 times 3/8 plus our 1/8 out here to the side. And now we're going to put parentheses around the multiplication. This is showing order of operations. This is telling us, the parentheses tells us that we did that multiplication part first, didn't we? We jumped 1, 2 times, and then we jumped the 1/8. All right, how do we feel about that? Cornelius, get your arms out of your jacket. All right, how do we feel about it? Crystal? Crystal?
Crystal. Shiny crystal. Glass.
What don't you get? What about it?
Sky.
Okay, but what was the actual jump? Which fraction did I jump to? 3/8. So you wouldn't do 2/8 because 2/8 wasn't even shown here. All right, and again, because, and this is why I said, what is the definition of multiplication? Repeated addition. Which one did I repeat? Which one did I do over again? 3/8 and 3/8. And how many times did I do them? 1, 2. So that's where I get what I multiply by. Okay? All right, let's look at another problem. All right, for this one, a number line. The first endpoint is always going to be 0. Your last endpoint is going to be 3. Now, the numbers that I put above the number line are what kind of numbers? Whole numbers. So these are whole numbers. I have a 0 and 3 wholes. Where are the 1 and the 2? Here. On the top of the line? On the top of what line? Where? On the top of the number. Where? Right here? No? So what? Where is it going to be? The one right beside the 0? If this is a number line, what we need to think about with number lines is that everything is proportional. Okay? So let's think first. Let's not think of just whole numbers just in case that confuses us. Let's think of just fractional parts or just parts of a number line. I want to divide this number line into 3 sections. So the first thing you can do is 1, 2, and now I have a whole number 1, and I have a whole number 2. Go ahead and write that on your paper. Whole number 1 and a whole number 2. All right, now I want you to take your number line and I want you to divide each whole section into half. Each whole section into half. So where are my whole sections? Is this a whole section? Yes. So divide this whole section in half. Divide this whole section in half. And divide this whole section in half. All right, now we're going to label it. What is this first line here? What is it? 1/2. So then, what is this line? This next line? Huh? 2/2. So it is 1 whole, but if I'm doing it as a fraction, I would label it as 2/2, right? All right, what is the third line? Y'all go ahead and say it.
1/2.
Okay, let's not all say it, because I had like 15 answers. All right, Emma. Nope, not just a half. Think about it in terms of every line. So we're going in consecutive order here. 80. 3/2. This is the third line, and our number line is divided in halves. All right. So then the next line would be what? Maitland. 4/2. 4/2. The next line would be what? Ethan. 5/2. 5/2. And the next line, Mia. 6/2. All right. I want you guys to tell me something that you notice between these whole numbers and the fractions that they are equivalent to. What do you notice about those whole numbers and the fractions they are equivalent to? Brian? What do you mean they're being times by 2? 1 times 2 is 2. And so then you're saying it corresponds to the numerator. Okay? 2 times 2 is 4. And 3 times 2 is 6. Okay, yeah, that is something that is going on. There's something else. Cornelius.
How the old fractions are going to be like 2 fours.
Okay, so they're counting by 2s. They are. What else? Maitland?
They're even numbers.
They are even. Talia? Okay. Jabria? They're all equivalent to a half. Okay, yeah, they sure are. Jake?
They all have the same bottom number.
Yeah. Well, that's because our number line was divided into halves. Carter? Y'all are missing what I'm looking for. Think about it. Carter? How or why does it work out that way? Okay. All right. I like that word divide. I want somebody to build on that. Does anybody see a correlation between the fractions that are underneath the whole numbers and the whole numbers thinking about the word divide? Mayor? No. Zane?
They're all divided by 2.
All right, what do you mean? What's all divided by 2? Oh, never mind. All right. Emma.
So each, like the numerator is divided by 2 each time. So 2 divided by 2 equals 4. 4 divided by 2 equals 6.
4 divided by 2 equals 6?
No,
8. 8. 4 divided by 2 is 8?
2.
4 divided by 2 is 2. Okay, everybody look up here at the board. How many of you knew that this fraction line means the same as divide? Anybody ever heard that? Okay. The fraction line here, every fraction line means the same as divide. So if I have 2 divided by 2, I get what? 1. When I have 4 divided by 2, I get what?
2.
When I have 6 divided by 2, I get what?
3.
Every whole number is equivalent to a fraction, and every fraction, for that whole number equivalence, the numerator can be divided by that denominator to equal that whole number. Every single one. Okay? Pay attention, that's a little quick little mini lesson. Okay, I'm going to do some jumps. Do your jumps on your paper. Alright, who can tell me what my answer is? What is my answer? Not the equation. What's the answer? Talia. Alright, 6 halves or 3. Stop tapping, please. 6 halves or 3. Alright, there's my answer. What equation? What 2 equations can I come up with to show what I have modeled that gives me a sum or product of 6 halves or 3? Alright, let's say Jabria.
2 times 3 equals 6.
Okay, those are whole numbers though. Alright? Think real hard about it. You're almost there. What fraction did I land on? The first landing. 2 halves. How many times did I move 2 halves? 3. So I have a repeating 2 halves how many times? 3. So then my multiplication can be 3 times 2 halves. There's my multiplication sentence. Okay? What is my addition equation? Addition. Mia. 3 halves plus 3 halves? Is that what I modeled?
2 halves plus 2 halves.
There you go. 2 halves plus 2 halves plus 2 halves. Mara. All right, look, on your problem set that you guys are about to do, let's talk about that real quick. On the problem set that you're about to do, it's going to give you some sums. So for number 2 and number 3, you're going to have some sums given to you. So let's say you have a sum of 10 fourths. What kind of equation, this is what you're going to have to do in just a minute. What kind of equation can I make to show a sum of 10 fourths? Okay, let's throw out some examples here. Cornelius. if I wanted to get my hand really, really, really tired, I'm going to lose count in just a second. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's a shorter way I could do that? If I didn't want to do 1/4 plus 1/4 plus 1/4, what's a shorter way I could do that? Addie.
5/4 plus 5/4.
I'm going to come back to that one. But I want to answer this question first. What's a shorter way that I could show this repeated addition that Cornelius just told me? Aiden.
1/4 times.
Okay, so I could either do 1/4 times 10 or 10 times 1/4. Okay? And then, now Addie, you gave me another one. What's another one that I could do?
5/4 plus 5/4.
All right, so we could do 5/4 plus 5/4. What's another way that I could show Addie's repeated addition? Jabria?
2 groups of 5.
2 groups of 5/4, which would be 2 times 5/4. Okay. All right, does everybody understand what you're going to be doing on your problem set? Okay. I think what we'll do is when we come back from lunch, we'll start that problem set, okay?